Okay, sorry if I got a little rushed there. I saw the end of the timeline coming up here. But anyway, part two of this, I want to show you one last technique. I call it the inverse reciprocal technique. The book's not going to show you this, but I think this is a lot more real world situation here. So what we looked at before is, okay, here's the wire I'm going to run. I have high ambient temperature. I have more than 3 conductors. So after I derate, my wire is only good for this many amps. That's unrealistic. What's really going to happen is I need a circuit that is X amps. What size of wire do I need to run? So this technique is going to sort of allow you to do that a little more directly. You could do it the way I showed you. There might be a little bit of more guesswork involved. But in this case, let's say I need conductors for a 60 amp circuit. Okay, but I'm going to have 6 conductors in my raceway. So what do? I know I have more than 3, so I'm going to have to derate. So rather than just picking a conductor ampacity and derating it and see what it comes out to after I derate, I guess I should say I have XHHW and aluminum this time just to change it up, but that won't throw us. So anyway, what I'm going to do in this case, I already know I have more than 3 current carrying conductors, so I'm going to reference 31015B3A once again. I'm in this category here, the top one. I have 4 to 6 conductors. That tells me I have an 80% derating factor. Okay, so I had to derate my conductors by 80%. Another way I could approach that is I think you call this the reciprocal of that number. That's what I call it anyway. But so again, if you remember back in I believe it was 108, we talked about continuous loads, and we sort of had that reciprocal factor, 125%, 80%. It's actually the same idea, actually the exact same math in this case, coincidentally. But the reciprocal of 80% is actually 125%. So what if instead of derating my wires by 80%, what if I actually increased my load by 125%? So if we just kind of use that math theoretically, I'm going to take my 60 amps times my reciprocal derating factor of 125%, or 1.25. So it's actually going to tell me I need to find wire that can handle 75 amps. Okay. So what I do then is I go to 31015B16. As I said, for whatever reason I want to use aluminum XHHW in this case. Don't ask me why. But we come down here, we need to find a wire size of aluminum XHHW that can handle 75 amps, and we find that happens to be number 4 wire. Okay, so simple as that. We'd run number 4 AWG XHHW aluminum. So again, that in my mind gets me direct to the source. I don't have any guesswork. I can just simply do the math one time, go to the chart, find what I need. Alright, so again, you'll see more of these problems. Try to get comfortable. I think this is about as complicated as it needs to get. Anybody has any issue with these, please reach out, because this is a very important issue. The inspectors are looking for this in the field, so it's an easy way to get caught on something. So make sure you're comfortable with this one. Alright.